Hello and welcome to another eMathInstruction Common Core Algebra 1 lesson. My name is Kirk Weiler, and today we're going to be doing Unit 10, Lesson number 9 on quantifying predictability, also known as correlation coefficients. So let me remind you before we get into this that you can get the worksheet and the homework that go along with this lesson by clicking on the lesson's description right underneath the video, or by visiting our website at www.eMathInstruction.com. As well, keep in mind that at the top of all of our worksheets are those QR codes. That's going to allow you with a smartphone or a smart tablet to scan the code and be taken directly to this video. Let's jump into it though and discuss why we're going to talk about predictability. So we have to ask a very simple question. We've been doing some bivariate data analysis, i.e. two variables and how they relate to one another. Okay? But there's a really driving question, which is how good does a line of best fit, or a parabola, or an exponential of best fit, how well do they fit our data, right? Because we could have a good fit. We could have a line that matches the data quite well, in which case the equation of the line would predict what's going on with the data well, would predict it well, that the equation, whatever it is, y equals 5x plus 7, I don't know, right? That thing would predict that data well. On the other hand, you can also get poor fits, right? So now that line won't predict the data very well, right? If I go to some x value here, then this is what the line's going to predict, but that's the actual x value, or that's the actual output, right? Not a good thing. You could even have the case where there's an absolutely perfect fit. In other words, the line goes through all the data, and whatever the equation of the line tells you is exactly what the data would tell you. So what we need to do is we need to explore in this lesson a particular thing known as the correlation coefficient, and we're going to stick with linear the entire time, but we'll see it pop up here and there with exponential and quadratic. But we're going to be using correlation coefficients to try to quantify, assign a number, to how good the line can predict the data. Okay, I'm going to clear this out. And we're going to jump right into exercise 1. Exercise 1 is actually just a mechanical question, or not even a mechanical question, but a mechanical procedure with the calculators. Now there's lots of calculators out there. There's Texas Instruments, there's Casio, there's Hewlett-Packard, there's calculator apps that you can get for your smartphone. All right? All of them have what's called a correlation coefficient on them. It's also known as an R value. Okay? In fact, you'll hear me refer to them as R values. The Texas Instruments, which is the graphing calculator that I absolutely love, the default mode, you take it out of the package, the mode that it comes in, has the R value turned off, which boggles the mind. I don't know why they do that. TI, get on top of that. Just have it on. Anyway, I'm going to show you how to turn it on the TI-84 Plus. The same thing will work with the TI-83 Plus, the 83, the 84, etc. So let me open up the TI-84 Plus right now. We're going to need the calculator a lot today, so let me open it up. All right, hello calculator. Let me show you how to do this. It's very, very kind of technical. All right, so what we're going to do is we're going to go to the catalog. All right, so that's simple enough. It's right down towards the bottom of the calculator down there. So I'm going to hit second and go into my catalog. Now I need to go all the way down to the D's. Now you can scroll through that, but one of the beautiful things about the TI is right now what's known as alpha lock is on. So if I hit the D button, which is right above the X to the -1 button, if I hit that, it takes me right down to the first D. And what I need to do is scroll until I see something called diagnostics on. They couldn't have even given it a nice name. They could have said correlation on or R value on, but no, it was diagnostics on. So I'm going to hit enter on that. And the calculator just tells me done. And that turns my R value on. I know that's silly. It's an irritating procedure, especially when you get your graphing calculator cleared right before a test and you need to have it on. But remember, diagnostics on, turn that R value on, and we are ready to go. I'm going to clear that text out, and we're going to figure out what that R value tells us. So exercise number 2. In the following exercises, 4 data sets with equal x values are given to illustrate different types of positive correlations. Now remember, a positive correlation means that as x gets larger, y will get larger. A negative correlation is one where as x gets larger, y gets smaller. Anyway, it says for each, enter the data, observe the scatter plot, and record the r value, known as the correlation coefficient, for a linear fit. So we're going to do a linear correlation, although quite frankly, what we're not going to care about today at all are those linear equations. We're just going to care about the r value to the nearest thousandth. That might seem like some extreme rounding, but you'll see why. To the nearest thousandth, and we want to look at the scatter plot. So let's enter some data. All right, on the TI-84 Plus, let's go into our list. Let's go to Edit. We've done this a couple different times in the course, right? Especially in the last few lessons where we were doing linear fits and linear regression equations. Let's clear out any data we might have in the lists. That takes maybe a little bit of time, and we don't want to delete the lists. All right. If the data is all clear, let's very carefully enter our x values. So 2, 5, 8, 11, 15, and 18. Scan those x's, make sure they're right. Now let's do the y's. 4, 13, 22, 29, 43, and 52. Again, take a good look at your data. Check the y's, check the x's. One of the things I did in this exercise is I kept all the x values the same. So what we'll do is every time we'll go in, we will simply change L2. We won't change L1. Now I want to do 2 things right now. I want to calculate the correlation coefficient, and I also want to look at the scatter plot. We'll do the correlation coefficient first, okay? So let's get back out to the main screen. All right, let me show you how you're going to do this. So to calculate the correlation coefficient, what you're going to do is you're going to, I have to look down at my calculator a little bit. All right, you're going to hit the stat button. All right, you're going to go over to the calculate command, and you're going to go down to linear regression. Now you've done this quite a few times recently, but hit return on it. All right, that pops you out to the main screen. Hit enter again. Bunch of stuff. You even see something called r squared. But eventually what we find on here is that we have an r value that when rounded to the thousandths, that's 3 decimal places, is very close to the number 1, right? It's 0.999, very close to 1. Now let's see what the actual scatter plot looks like. Let's review how to do that. So what we're going to do is we're going to go into our stat plots. Now remember, to do that, what you do is you hit second y equals. Then we're going to go into stat plot 1. Okay, we're going to make sure it's on by hitting the on. Then we're going to go down. We're going to choose scatter plot, which is that first one. Then we're going to change the first thing into L1 if it isn't already. And we're going to make the second one into L2. Now, if you've got something else besides L1 and L2 in there, you can get to L1 and L2. You can actually get to them by hitting second 1 and second 2. Look at the calculator and you'll see L1 and L2 hanging out right above 1 and 2. But let's take a look, make sure that that's all set. All right. Now, one thing I always want to make sure I do is make sure I don't have any equations right there, because I don't want to graph any equations at the same time I'm graphing data. So real quick, I'm going to hit y equals. I'm going to clear out any equations that are in here. All right, and now we're good to go. The stat plot's on. Oh, we're not good to go. We need to set up the window. That's right. Let's go into the window. All right. Now, what's kind of cool is that we have our x values sitting in front of us. So what I think I'm going to do is I'm going to make my x values go from 0 as my minimum to 20 as my maximum. The reason being is that'll get everything from 2 to 18 in there. And now I think for my y values, what I'm going to do is I'm going to put 0 in for my minimum. And I think I'll put, let's go with 60 as my maximum. All right, now we're ready to go. All right, our window's all set, our data's in there, all equations are turned off, and graph. Look at that scatter plot. It's almost perfectly linear. I mean, it is very close to a straight line. So that is a great linear. Or now let's use the terminology we used last time. Let's call it a strong positive fit. So a strong positive correlation. In other words, the data come very close to lying on a straight line. All right, now we're going to be able to speed this up a little bit. Okay, we're going to go back into our data list. So let's do that. Let's go back into our data list. All right, hitting Stat and Edit. Okay, we don't have to change list 1 at all. We just have to change list 2. So let's put in 16, 14, 22, 41, 37, 51. All right, let's hit the Stat button. Let's go down to linear regression again. Let's hit Enter. And again, just watching my rounding a little bit there, I'm going to have R equals 0.930. All right. Now, what's great is our stat plot is completely set up already. All right, we've got a good window. We've got it completely okay. So all we have to do is hit the graph button now. So definitely a linear trend, right? Definitely the y values seem to be getting larger as the x values get larger. I think I'd maybe classify this as a moderate positive correlation, right? There's some correlation. It's not great, it's not terrible, but moderate positive correlation. All right, let's keep going. Let's go back into our stat. Let's go back into edit. And let's change those y values again, or not the y values, but the L2 values. They are y values. So let's put in 18, 8, 41, 28, 62, and 44. All right, make sure those are all correct. Again, the beautiful thing is we are ready to go. Let's hit the Stat button now. Go down to linear regression, hit Enter. And let's see, I can now say R is 0.776. And let's take a look. Let's hit graph. Ooh, well, I think it's definitely a positive correlation. Y kind of seems like it's getting bigger as x gets bigger, but I think I am definitely going to call that a weak positive correlation. All right, let's do one more. Here we go. So back into stat, back into edit, and list 2. 44, 51, 30, 55, 45, and 47. All right, again, check my data. Okay, let's do the linear correlation. Let's go to Stat, Calculate, Linear Correlation, Enter. And we now see that our R value is 0.133. All right, well, let me pop out of here for a second. Let me go right to the graph. Let's hit graph. Oh, ooh. So I'm going to say almost no correlation. And that is all over the place. Almost no correlation. So letter D, how does the correlation coefficient quantify the fit of a positive correlation? Well, here's the way it goes. When R is 0, there is absolutely none. Absolutely no correlation Whoops. Oh, nuts. I left out an extra R. Let's do this. How about no? Thank you. I know I selected the pen. No correlation / predictive ability. On the other hand, if R is equal to 1, it's a perfect correlation. And I'd say predictive ability. So what that means is that everything else, at least with positive correlations, lies in between. The closer you are to 1, the better the equation will do predicting your data. The closer you are to 0, the less you should trust it. All right? All about the R value. R's of 0, bad. R close to 1, excellent. All right? You can almost think of it as a percent. You know, it's like almost think of it as the percent that the model's going to get right. You know, 99.9% in letter A, 93% in letter B, but by the time you get to letter D, that model's only like 13% correct. That's not exactly the right way to look at it, but it's a helpful way. All right, I'm going to clear this out because now what I like to do in exercise 3 is I'd like to take a look at negative correlation, and what happens with the R value then. All right. Now the beautiful thing here is that we've kept the X values the same. All right, we've kept them the same. So we just need to open up that TI-84 Plus again, and we need to go into our stat, go to edit, and now only change those L2 values again. So let's put in 52, 47, 28, 32, 25, and 10. Again, pause for a minute just to look at the data. Never know when you're going to miss one. It's a little slip. All right, so let's hit stat. Let's go over to calculate, go down to linear correlation, enter, and we have an R value of negative 0.945. So we didn't see that at all. We didn't see negatives at all, right? Now, let's look at the scatter plot. Again, we've got everything in there we need. So let's just hit graph. And that's actually not bad, right? In fact, you could say that that's a moderate to strong, a moderate to possibly even strong negative correlation. Right? A moderate to strong negative correlation. So how's the negative correlation reflected in the R value? Well, when you have a negative correlation, that will result in a negative R value. All right, negative correlations correspond to negative R values. So what's really cool is we can summarize this now very, very easily, what the R value tells us. I'm going to clear this out, so write down anything you need to. All right, it's gone. So let's summarize it, right? Correlation coefficient summary. It's pretty simple because on one end of the spectrum, you get a perfect positive fit, and R is equal to 1. On the other end of the spectrum, you get a perfect negative fit, and R is equal to negative 1. Right in between the two, you get just no correlation at all, and R is equal to 0. Everything else is in between, all right? So you could literally say, look, you got this terrible looking number line that goes from negative 1 to 0 to 1. 1 and negative 1 are both perfect. They're absolutely perfect fits. Everything else lies in between, right? So, in this realm, we're going to have strong fits. Strong? How about strong? That's supposed to be an N. Anyway, in here we might have moderate. And in here, we might have weak fits. And then the same thing would happen here. Here, we would have a weak fit, but negative. Then we might have moderate fits. And then we'd have strong fits. Right? So the correlation coefficient, the R value, goes from -1 to 1. All the negatives tell you are that the slope of the line is negative, right? That as x increases, y decreases. But then how close they are to -1 and 1 indicates how good those linear regression models will predict what the data is doing. Okay? So I'm going to clear this out, and we're going to actually do some kind of quick problems now. All right, take a look at exercise 4. It says, given the scatter plot shown below, which of the R values would most likely represent the correlation between the two variables? Explain your choice. Well, if you think you know what's going on now, pause the video and figure out which one's correct. All right, let's talk about it. Well, what do we know? We know there's definitely a positive fit, right? So there's definitely a positive correlation. If you drew the line of best fit, it would look maybe not quite like that. The line would actually be shifted down a little bit. But it's a positive fit, which means a positive R. Okay, that means this one's out. That's a negative R. Now, it's a pretty good fit, right? It's pretty strong. So that one's out. And it's not a perfect fit. See, if they all fit right on a line, it would be R equals 1, but they don't. So R equals 0.88. I don't know if R really is 0.88, but it's the only choice that works. I'm clearing this out. All right, let's do another quick one. Exercise number 5. Which of the following scatter plots would have a correlation coefficient closest to -1? Pause the video again and think about this. All right. Well, we need a negative correlation, right? We need a negative correlation. This would be a positive correlation. This would be a negative correlation, and this would be a negative correlation. Ugh, terrible lines. This would be no correlation, right? Think about it this way. If you drew a line through there, how would you know whether it had a positive slope or a negative slope? So we need something that's closest to -1. This is out because it's no correlation. This one's out because R is positive. So the question is, which one of these would be closest to -1? Well, -1, remember, R equals -1 is perfect. All the data would lie in a line. Of 2 and 4, 4 comes closer to lying in a straight line than 2 does. So there's our answer. All right, I'm going to get rid of this. All right, let's do one more problem. Okay, the whole point of the correlation coefficient really is to tell you how good a linear model or other types of models will do in predicting something. This is very wordy, but let's look at it. There are two primary types of crude oil sold in the world: West Texas Intermediate, also known as WTI, and Brent crude. Each is priced differently on a daily basis, and each has a correlation with the average price per gallon for unleaded gasoline. So, the gas you buy depends on the oil that it's made out of. Two linear regression models, along with their R values, are shown below. Give a prediction for the price per gallon of unleaded gasoline, Y, so Y is the price per gallon for gas, on a day when the price for WTI is 103 and the price for Brent is 109, and those prices are the X values. Which model did you choose and why? All right, pause the video and see if you can answer this question. All right. Well, first things first, which model should I use? I could calculate the price of gasoline for both, but why don't I just pick the better model? Well, this is going to be the better model. That's going to be the better model because R is closer to the number 1, right? 0.973 is closer than 0.924. So I should use this model. Now that's the model for Brent crude. So what they tell me, they said Brent is $109, okay? The price of gas, well, that's my Y. So I'm going to put 0.028 times 109 plus 0.71, I find that that ends up being 3.76 once I round it to a reasonable level. 376 a gallon. Again, the important piece here is that I'm going to use this model because its R value is closer to 1 than this model. All right, that's it. Let me clear it out, and then we'll finish up the lesson. So either using our hands or using technology, we can find lines of best fit for data sets. The question is, how much should we trust the equation for the line of best fit? When we have R values that are very close to 1 or -1, well, we can trust that model. It's got great predictive ability, great predictive power. On the other hand, when R values are very close to 0, one would say that the linear model, or any type of regression model, does not predict the data well. All right, well that's it for today. Thank you for joining me for another eMathInstruction Common Core Algebra 1 lesson. I'm Kirk Weiler, and until next time, keep thinking and keep solving problems.